Our first speaker is Pankajaksha Mohanta, and he is a BSc final year student at Karanjia Autonomous College, Odisha. So he will speak on Thomae function. Yeah, Pankajaksha.
Hi, good evening to everyone. So, today we are going to discuss about a special type of function. So, first we define that function. Function is defined on 0 1 upon interval and 0 1 upon interval to real number. And at rational points, when x is it belongs to rational number between 0 and 1, its value goes to 1 by q, where x equal to p by q and p and q are natural number and they have no common factors. And at irrational point of 0 1, its value goes to 0. Our main aim is to discuss about the continuity of this function on its domain. So there are two cases arises. One is it continuous or not at rational points, or and another is it continuous or not at irrational points. So let's talk about first point. When is it continuous at rational point or not? Let a point a point A belongs to rational point number between 0 and 1. So first thing is we need to estimate this, that is f of x minus f of a of modulus. If x is a irrational point between 0 and 1, then modulus of f of x minus f of a, that is f of x, since it is an irrational number, that means f of x should be 0, and since a is a rational number, f of x should be 1 by q. F, that is modulus of f of x minus f of a equal to 1 by q. If 1 by q is less than epsilon, then we have done it is continuous. But if 1 by q is not less than epsilon, that is if 1 by q is greater than equal to epsilon, then problem arises. So if we choose x equal to p by q such that 1 by q is greater than epsilon, then modulus of f of x minus f of a need not be less than epsilon. That's that's create problem for us. So it is not continuous. So now we are going to discuss the test proof. Suppose we have to prove this by method of contradiction. Suppose f is continuous at a, that is given any epsilon positive, there exists delta positive such that given any x belongs to a minus delta to a plus delta, f of x belongs to f of a minus epsilon to f of a plus epsilon. That is, in another way, given any epsilon positive, there exists delta positive when any x belongs to 0 1 with condition x minus a is less than delta, then f of x minus f of f modulus less than epsilon. If we choose epsilon equal to 1 by 2 cube, which is greater than 0, because q is a natural number and 1 by q 1 by 2 q is strictly greater than 0, and we choose x is any irrational point between 0 and 1 with condition x minus a is less than delta, then from equation 1 we get f of x minus f of a less than epsilon. Since x is an irrational number, that means f of x equal to 0 and f of a equal to 1 by q. So 0 minus 1 by q, 1 by q. And we choose epsilon is 1 by 2 cube. That is 1 by q is less than, strictly less than 1 by 2 cube. 1 by 2 cube, which is a contradiction to our, which is a contradiction. Hence, our function is not continuous at any point, at any rational point between 0 and 1. So we prove this. Now, second part. If A is any irrational point between 0 and 1, that means f of A equal to 0. Now, again, we need to estimate f of A minus f of x minus f of A modulus. If x is irrational number between 0 and 1, then f of x minus f of A modulus is equal to 0. So, it is less than epsilon. It is easy. If x is belongs to any rational number between 0 and 1, then f of x minus f of A, the modulus should be 1 by q. So, if 1 by q is less than epsilon, that means f of x minus f of A modulus is less than epsilon. It is only possible for those x equal to p by q such that 1 by q is less than epsilon. There will be a problem if 1 by q is greater than equal to epsilon. So, our aim is to eliminate those points from the a minus delta to a plus delta, which are bad elements. That means 1 by q is greater than equal to epsilon. We have to remove those elements. So we collect all those elements and throw out from its domain. So let we define a set E. We collect all x equal to p by q such that q is less than equal to 1 by epsilon and p and q are natural number. Since q is less than equal to 1 by q and q is a natural number, so q is a finite, q has finite number of choices, and p x equal to p by q, which is belongs to 0 1. That means p is strictly less than q. Since q has finite number of choices, so p has also finite number of choices. That means p by q has finite numbers. That means E has finite number of elements. Let's say x1 that's contain n elements, x1 x2 up to xn. Now we take a is any irrational number between 0 and 1 and xk is a rational number. That means though a is not equal to xk for any k between 1 to n, therefore xk minus a modulus is strictly positive for any k. Now we are choosing delta. Delta is the minimum of xk minus a the modulus, and it is strictly positive. So if we choose this delta, then our bad elements are eliminated from our domain. So text would prove is let epsilon be positive given and choose delta equal to minimum of xk minus a modulus. 1 is less than equal to k and less than equal to n, which is positive. Then given any x in 0 1 with condition x minus a is less than delta, then we have f of x minus f of a equal to 0 when x is a rational number between 0 and 1 and 1 by q, which is less than epsilon if x is a rational number between 0 and 1, since we throw out all those bad elements. So from here, for given any epsilon positive, we can find a delta such that f of x minus f of h less than epsilon. So f is continuous at irrational number in 0 1. So finally we conclude that we can find such a function which is continuous at irrational number of 0 and 1 and discontinuous at any rational number between 0 and 1. Okay, this much. Any doubts?
Okay, thank you, Pankajaksha.
Yes.
Any questions, comments, suggestions?
Yeah, Pankajaksha.
Yes.
Okay, I
So-
have a question, Pankajaksha.
Yeah.
Yes. Yes.
Can you go to page 2? Page 2 where you have written Q is finite. Scroll down.
Yeah.
Since Q is less than equal to 1 by epsilon and Q is belongs to N, so Q is finite. So what do you mean by that? Q is finite?
That means saying Q had a finite number of choices.
And how does this follow?
Because Q is less than equal to 1 by epsilon and Q is a natural number. So less than equal to greatest integer of 1 by epsilon. So
Okay. So are you using any property here of real numbers to say that Q is finite? I mean, Q has finite number of choices.
yes. That is Archimedean property.
Right. So Q epsilon is less than equal to 1.
Yeah.
Correct. Okay. Thank you. Alapan.
Yeah. So Pankajaksha, you are like dealing with this discontinuity kind of functions.
Yes.
So can you tell us like you are aware of a Dirichlet function, no?
Yes. Yes.
Yeah. So Dirichlet function and say, can you tell us about that also if that is continuous or
And
continuity?
Dirichlet function is at rational points its value is 0 and irrational point is 1.
Okay, you take that. Okay. Yeah, you take
It's
that function. Yeah.
not continuous at
Can you repeat?
and it is not continuous at any point.
Okay. Can you tell us why? Not a proof, but just a intuition is okay.
Uh, if we talk about any point about rational points, then there is a irrational function, a sequence which converges to rational number by
Okay.
the density of irrational.
Okay.
And then suppose it is continuous, and then since an converges to a, so f of x also converges to f of a. What f of an is 0 is a constant sequence and f of a is 1. So a constant sequence 0 but it converges to 1, which is a contradiction. So it is not a continuous.
Oh, correct. Okay.
The similar proof is from for another irrational point.
One way is okay. No?
Yeah.
Okay. I mean, you want to argue for both, like rational and irrational. Then both way needed. Okay.
Yes.
Thank you, Pankaj. Kiranda, you may proceed.